Okay, so we're going to work on areas between curves. This lesson typically isn't too hard, and this lesson is like almost always, if not always, on the AB portion of the test. So I would say about half of the time questions like this are on the BC test. Because what they do, there's 6 questions for free response on the AB test, and 3 of those questions get put on the BC test. So you'll have 3 of the same questions as the AB students have. And then the other 3 are BC concepts, but a lot of times the BC concepts involve AB stuff in them. So really the majority of your test is this AB stuff, but sometimes you have to like know BC stuff to finish the question or to get all your points for that BC half of it. But area between curves, all you're going to do is you're going to find the area under the top curve, which would give you this entire thing here. And then you're going to subtract the area under the bottom curve, and that gives you the area between the 2 curves. Okay, so typically they'll ask you for area between curves for part A, and then they'll do like a volume of revolution, which is 5.2. We'll do that on Monday. And then they'll do like a cross sections, which we'll talk about on like Tuesday, Wednesday kind of time frame. But this lesson is really important to make sure we know because it's on the AP test all the time. If they don't have it on a free response question, they're going to have it on a multiple choice question. So what you do is you take the integral from A to B, take your top curve and subtract your bottom curve. This works even if it's under the x-axis, so don't think you have to flip them or anything like that. If you take your top curve and then you subtract your bottom curve, you're taking this smaller negative and subtracting a bigger negative, so it's going to give you that positive area that you're looking for, even if it's below that x-axis. Okay, so just top minus bottom. All right, so if we're doing something like this, it's quicker to do it this way, to find the total area from this spot all the way over to this spot. Instead of trying to find this intersection point and go from A to C and put your F on top and your G on bottom, and then write another integral that goes from C to D and put G on top and F on bottom and then add those 2 together, it's way quicker just to throw an absolute value around it. And then it doesn't even matter which function you put on top, and you can just go the entire way from A all the way to D. And again, if you flip these, it doesn't matter because it's absolute value, so that negative is going to turn positive. So this is way quicker when you're using your calculator. And a lot of these are calculator active problems. If it's not calculator active, you might have to, think about it a different way or really know how to do the absolute value, which we do know how to do. Every once in a while, though, they will say to write an integral. So a lot of times they'll say write an integral but do not evaluate. So if they say that, then you just write the integral and you're not actually putting in your calculator and finding your answer. So they're not giving you an answer point, they're just giving you the setup point. But sometimes they say without using absolute values, write an integral. So if you can't use absolute values, then you would take this one here plus this one here and you'd write it that way. Okay, but if you're allowed to use absolute values, which most of the time you are, you can do it with that. So any questions on the concept of it? Okay, then we're just going to go ahead and try a couple problems here. So the first problem is taking this parabola and this line and finding the area between. So let's just set up the integral quick. Am I going to do this with respect to x or y? X. Because it's just your normal one. So what do my x's go from here to here? 0 to 4. Take our top curve, which is 5x minus x squared, and then you subtract your bottom curve, which is x. And we can all evaluate that either by hand or in our calculator, right? So questions on that at all? You could even put your x's together before you do your antiderivative. Okay, number 3. Go ahead and go to page 349 because I'm not very good at sketching that one. but I want to talk about it quick before we go into our calculator problems. Okay, so if you're looking at this in your book here, there's a couple ways to do it. The easier way is to flip it on its side, so then this is the top curve, and this is the bottom curve. And the blue one's the top because it's the positive x-axis. Sometimes people end up with those backwards. If you end up, and it says find the area, if you end up with a negative area, is that possible? No, when it says find the area, area has to be positive, okay? So if you end up with a negative, I would not go back and redo all of your work. I would say, okay, you did the integral, you accidentally did it backwards, you get -4 for an answer. Say, therefore, your 3 dots, or write out therefore, the area between the curves is 4, and just leave it at that. They still have to give you credit for that. Obviously, you could go back and switch your top and bottom ones, and it should flip that negative to a positive, but that requires extra time. So the easier way is to set up your integral with this on top. What is this equation then going to be in your integral? Square root of y minus y squared minus 1. You have to subtract the whole thing, so I'd turn into a +1, going from 0 to 1. Okay, and then you can do that in your calculator if you have it, otherwise do it by hand, it's really easy. The other way to do this, let's say this was in terms of like a y equals equation, and so was this, you could go from wherever this spot is here to here, and you would just do the area under the red curve, and that would give you this piece of it. And then how would you do this piece?
Can't you take the integral of y equals 1 minus your square root of y?
Yep, so you would go from here to here, and your top equation would be 1, and then you would subtract this equation here, but you'd have to get it in terms of y, so it would actually be y equals x squared. So it'd be 1 minus x squared in that integral. So sometimes it's easier to flip it. I would say with these problems it is easier to flip it because you're just dealing with one integral, but there are 2 ways to do it, okay, for a lot of those where maybe you don't want to flip it, or it's not in terms of something where flipping it makes it easier. You can always split it and do it that way, okay? Okay, so we're going to go ahead and try this example. Put these into your calculator and try to get a good screen so that you can find the area, and then set up the integral, and we'll check it here. I'll give you 2 minutes to do that. So when you put those into your calculator, is this kind of what you get if you have a really good screen? So the red one is what equation? Which one's top? E to the x, right? And on the bottom we've got the sine of x. So then when you set up your integral, x equals 0 is just a vertical line here. X equals pi over 2 is a vertical line at pi over 2, which I think I just made the end of it here. So we would go e to the x on top, and then subtract sine of x on bottom, and then throw a dx in the back, and our limits go from 0 to pi over 2. And does everyone know how to put that in their calculator quickly with the integral under the math button? You can go to your graph and have it shade it. That works too. But the easier way to do it here is to go math and then go down to the integral, which is 9 on mine. And then you can go from 0 up to pi over 2. And then you put your equations in. Now if you have, let's say these are really long and annoying equations to type, and you already have them in your y1 and y2, then you can go into your vars and just go y1 minus y2, and then you're not having to type them again. But I don't have them in mine. So then you just put your e to the x minus sine of x, then back here you put with respect to x, that's your dx, hit enter, and it gives you your answer. So what do we get for an answer for that one? 2.810, or, yeah, 2.810 is the only answer that would work there. And if you don't put the 0, they assume it's a 0 there, so 2.81 is fine, or you could write 2.810. Okay, so any questions on that at all? Okay, let's go to example B then. Get that in your calculator, and we'll check that in 90 seconds. Go ahead. Okay, so if we put these in our calculator, and we're trying to find the area between the curves, most people come up with that window. Is that what you guys did? Okay, what did you do then? Did you do it correct, do you think? Okay, so you got an answer of 4. That's what a lot of people get for an answer. I guarantee you that would be an answer on the AP test, but it's not the full area. This is the area between the two curves here. But if you zoom out a little bit, think about where these hit each other. There's another one, right? So if you found that first one here and you went from, what was it, 0 to 2? And whichever equation's on top here, it must be the linear one. So we've got 3x minus the x cubed minus x. We could just double that area because that area is the same on the right and on the left. So you end up with an area of 8 total. Okay, 4 is a very common answer because you look at this part here, you get your answer. But you have to make sure that that's the entire area that's encompassed by those. Okay. Now, are those curves going to intersect anywhere else? No. So then we know we're done. But you always have to think, are these going to intersect anywhere else? And they will catch you on that on the AP test because a lot of times people use this, standard window and they think they have their answer and they have an answer for that, so you feel like you're done. Always think of what those curves look like and are they going to intersect somewhere else, okay? But these ones, that line and that cubic function, that'll be all the intersection points. Any questions on that one? Okay, let's go to example C. And again, I'm going to give you a couple minutes to get a head start here. Let's take a look here. So looking at the graph, you probably got a graph that looks like this, but it might be hard to know exactly what you're trying to find the area of with something like that. So your 1 over x, you got a piece down here and a piece up here. X equals 0 is also known as the what? Y-axis. Okay, x is equal to 0 at every point on the y-axis. So that's like this line here. And it goes all the way up and down. Y equals 1 and y equals 2 you have on there. So really the area you're trying to find is the area enclosed by all of those. So it would be that chunk right there, which obviously you could just zoom in on that piece then. But this graph doesn't intersect any of those other pieces, so there's no area enclosed with that. Okay, so we've got this piece here, and there's 2 ways to go about finding that area. Which way would be easier in terms of y? So make sure you put a dy back here. What do your y's go from? 1 to 2. So set up everything that you can here. Okay, and the blue equation is what equation? Y equals 1 over x, right? So if we solve this for x equals, multiply by x on both sides, and then you divide by y, so x equals 1 over y. And isn't that my top equation when I flip? So that goes first. And then you subtract your bottom equation. What is your bottom equation there? 0. So if you don't write the 0, that's obviously just fine. Okay? And then taking the antiderivative of 1 over y is just what? Natural log of the absolute value of y. Here it's not going to matter with absolute value symbols because they're positives, but you have to be careful of that because sometimes you don't have positives here. And then we got natural log of 2 minus natural log of 1. Natural log of 1 is 0, so we just get natural log of 2 for an answer. Okay, now the other way to do it would be to split it and go from here to this intersection point. and then you put 2 on the top, 1 on the bottom, and then you go from here to here, and you put 1 over x on top and 1 on the bottom, and you get the same answer in the end, okay? So part D, go ahead and get that one set up. So when we get our graph, we should have something like this, and you have to be careful that you look at your parameters that they're giving you here. So x equals 0 is over here, it's a vertical line. X equals pi over 2 is actually way over here. And you want the area that's enclosed by that entire thing, all of these graphs combined. So this part here is enclosed, which you probably found. But then there's also this part here that's enclosed because of that x equals pi over 2 piece. So again, there's a couple ways that you can do this. You can find, did anyone find this intersection? 1.047. You're going to want to go out more spots than that if you're going to use the 1.047 piece. Because if you just use 1.047, you do the integral, it's not going to make, your answer is not going to be correct to 3 decimal spots. We'll use that for right now. So you could go from 0 to that 1.047 and figure out which one's on top. So which one's on top there? Is it this one here that's on top? So we got sine of 2x on top, and then we subtract, and the blue one's on bottom. And then what else do I have to do? So what's the other piece I still have to do if I do this way? Okay, and then we flip them, right? Because now sine of x is on top, and then sine of 2x is on bottom. And sometimes they'll force you to write it this way on the AP test. What's the quicker, easier way to do it if this is like multiple choice? You do absolute value, and we can go then all the way from 0 to pi over 2. Put our absolute value. Let's say we assign this y1 and assign this y2. We can just do y1 minus y2. And dx goes in the back because those are x's in there. And they give you the exact same answer either way. Okay, so if you have your calculator, does everyone know where absolute value is in your calculator? You hit the math button, right, and it's right under there. There's absolute value, and then you can do that. And if you have them already in your y1 and y2, you can just type the y1 minus y2 in your calculator, and you're good to go. Did anyone get an answer for that? 0.5. Like my calculator came up with 0.5000024,519. So 0.5 would be correct to 3 decimal spots, and I'm assuming that's a rounding thing in the calculator. So questions at all? Okay. Efficiency is pretty key on that AP test. So 35 here. Let me just write the equations down, but if you have it in front of you, that's fine. I've got y1 is 3x squared minus 2x. And y2 is x cubed minus 3x plus 4. Okay, and let's try this one without absolute values first, because like I said, sometimes they throw it in there and they say you cannot use absolute values, write an integral expression that represents the area between the curves. Think about what type of functions you have here. We have a parabola that opens up, and we have a cubic function with a positive coefficient in the front, so make sure you find all the intersection points of those graphs. Okay, it's easy just to find a couple of them and say it's good. When we're looking at this here, if you zoom out, this red cubic function is going to increase at a faster rate than this blue parabola. So they're going to actually intersect another time up here. So there's this area here that you would miss if you weren't thinking about what types of functions those were. Okay, so let's find these intersection points pick an intersection point to find. This first one here I'm just going to call A, and somebody find what A equals for me here. Negative, sorry, 1.1149. I'm going to add a couple more, 08. Okay, and then let's find what B is here. And then what C is out here. And if we define what these are within the problem, then we can just use A, B, and C on our integrals when we're writing our answer. So B, what are we getting? That looks good. And then C, I'll get here, we got 2.860859. 059, I mean. There we go. So if you write what those are here, obviously you're going to have to type them in your calculator, but when you're writing your answer, you have them defined within your problem. So we're going to go from A to B. And which function is on top from A to B? The cubic function, right? And I have that defined here as y2. So I'm just going to write y2 rather than writing the whole cubic function minus y1. As long as you define it within that part of the problem, you can use those down here then. And that's with respect to x. Remember, if you plugged this in, it would be all x's in there. And then plus, and then we're going from B to C, which we have here. And y1's on top now. And then y2's on the bottom. And then if you had to evaluate it, you sure could. We would get 8.378 if you want to have that on your paper, but I'm not going to make you type it in your calculator. Okay, if you were able to use absolute values, then you could just do the absolute value from A to C, and you can put whichever function on top and whichever function on bottom. Okay, then sometimes they do things like this. I would say more rarely, but they always try to throw something new on there that tests if you understand things. Use the midpoint rule with n equals 4 to approximate the area bounded by these graphs. So I've got my graphs here. Let's just use those. Okay, x equals 2 is over here, so I'll draw that piece on here. You might just want to do a little sketch of this on your page there. And we want our n to be 4, so the area is this area here. And if we're splitting that into 4 pieces, we're starting at this spot, so starting at 0, going out to 2, splitting it in half, and then splitting it in half again. So this gives us 4 rectangles there. And now these are weird. Let's get a spot here where we actually have a little bit of room to show it. So we use the midpoint rule. So what you're doing is you're going at the midpoint of one of your intervals. I'm just using this one because it's easier to see. So you go at your midpoint, you take your top curve and your bottom curve, and then you would draw a rectangle. And they're not going to make you sketch the rectangle, but this is what you're finding the area of here. And you would find the area of all 4 of those and add them together. Just a second here. Okay, so then you could set this up. You'd use your calculator for this and use the table in your calculator. With the table in your calculator, what value would you want to start at? 0.25. You want to do the midpoints, and you would want to go by what increments? Half, right? So you'd find all those spots, and you take the top one minus the bottom one, and then you'd have to multiply that by the width of those rectangles. Does that make sense? Okay, so here, if you take the top one and you subtract a negative, isn't that going to give you the height of that rectangle? You're taking a positive, subtracting a negative is going to add that piece on there, and then multiply by the width of a half, okay? The last page here, you're given a table of values. We'll go over this one in class on Monday. I'll make this homework due on Tuesday, but we're gonna start volumes of revolution on Tuesday, okay? So we'll go over this one, that way you can finish your homework up or whatever on Monday night, but try to get as much done for Monday as possible. And do you guys have the homework assignment on that sheet? Okay.